Let us now solve a quadratic inequality. So quadratic inequality problems come like this. This is an example of a quadratic inequality where instead of an equal sign, we have a greater than, smaller than, greater or equals to, or smaller and equals to. So this is not a quadratic equation, it's a quadratic inequality. So when we're solving this, we treat it as if we were treating a quadratic equation. Quadratic equation is x squared plus 3x minus 10. Sorry about that. X squared plus 3x minus 10 is equals to 0. This is a quadratic equation. So when we're solving a quadratic inequality, we treat it as if we were doing a quadratic equation. So we still factorize the same way we would if this was a quadratic equation. So we write our x's here. So now we want factors of 10. When we subtract them, they give us 3. So we want numbers, when you multiply them, they give you 10. When you subtract them, they give you 3. That is 5 and 2. Because 5 multiplied by 2 gives us 10. But 5 minus 2 gives us 3. When we have a negative here on our constant, then we know that these signs will not be the same. For more details, you can watch the video on quadratic equations on how to factorize. But generally, that's how we do it. When this is a negative, we will have different signs for these two. And the bigger number will take the sign of our x coefficient. In this case, it's positive. So our 5 takes the positive, our 2 takes the negative. If this was a quadratic equation, we would have x is equals to negative 5, and we would have x is equals to 2. But since this is a quadratic inequality, these are critical values. Call them CV. I don't have space, but you can always write CV in an exam or write critical values. So these are our critical values. What this basically means is that if we were to draw this graph, y equals to x squared plus 3x minus 10, if we were to draw this graph, it would cross, it's a smiling graph, since our x squared coefficient is positive, it would cross the x-axis at positive 2 and negative 5. Then we would have the y-axis somewhere in between. So what this question wants us to do is saying, basically it's saying, where is x squared plus 3x minus 10 less than 0? When is this y below the x-axis? Because we see this graph from 2 going upward, it is above the x-axis. From negative 5 all the way on this side, it's also above the x-axis. And then this graph is below the x-axis between negative 5 and positive 2. In this question, we are interested in the part where it is below the x-axis, when it is less than 0. So we're interested in this part. So the answer to this question, it is between negative 5 and 2. So this is when x is less than 2 and when x is greater than negative 5. That is the answer to this quadratic inequality. If this were greater or equals to, we would say greater or equals to also here. But this is how you solve a quadratic inequality. Let us do another example. Another example regarding quadratic inequalities. In an exam, they might give it to you like this. Solve x squared minus 18 greater than 3x. We still treat the inequality sign as if it were an equal sign. So if we have a quadratic inequality, we treat it as we would treat a quadratic equation. Something like this. X squared minus 18 equals to 3x, where we transpose the 3x and we bring it to this side. So this is a quadratic equation. We treat this as we would do that. So we now have x squared minus 3x minus 18 is greater than 0. We solve this as we would solve a quadratic equation. The sign comes back as it was. We have an x here and x here. So what now? We want factors of 18. When you subtract them, they give you 3. Two numbers that multiply to, and their product is 18. When you subtract them, you get 3. That is 6 and 3. 6 multiplied by 3 is 18. 6 minus 3 is 3. If we have a negative sign here on our constant, our signs here will be different. The bigger number takes the sign of the x coefficient. In this case, it's negative, so this one takes the negative, this one takes the positive. If this was a quadratic equation, we would say x is equals to 6. We would have x is equals to negative 3. But this is a quadratic inequality. It's not a quadratic equation. So these are just our critical values. Critical values. If you write CV and write these two numbers, you will still get this mark. So our critical values, they just mean that if we were to draw the graph of y equals to this thing, x squared minus 3x minus 18. If we were to draw this graph, it's a smiling face graph. Since our x squared coefficient is positive, it would look like this. The critical values mean the graph would touch the x-axis at x equals to 6 and at x equals to negative 3, with the y-axis somewhere in between. This is our y-axis. So now we want where this graph is greater than 0. So we want where it is above the x-axis. As you can see, the graph is above the x-axis all the way from here up to infinity, and all the way from negative 3 down to negative infinity. That is when this graph is above the x-axis, when it is greater than 0. That is all we are solving for. This is when x is less than negative 3. So it's for all of these values less than negative 3, or when x is greater than 6. So when x is greater than 6, that is where x squared minus 3x minus 18 will be greater than 0. So this generally is a 4 marks question in an exam. You'll get your 2 marks for your 2 answers. You get a mark for the critical values, and maybe get a mark for sorting out the quadratic inequality. This is how you solve a quadratic inequality problem in an exam.